Alright, today we're comparing different types of functions or models. And what we want to do is we want to learn how to select which function we want to use to represent the data that we have. So we have several different ways we can do that. The first way is by taking a set of points and creating a scatter plot. Now, in example 1, we're given 3 different sets of points. First set of points uses a bunch of fractions, which in and of itself is not significant.
Is that 10 or 0?
That's 0. That's a parenthesis right there. So if we plot these points on a graph, we should be able to see what type of equation we're graphing just based on the shape that it makes. Now notice that none of our outputs are negative. That starts to narrow it down right away, actually. So if we plot those, -4 1/32 is a really small output. -2 1/8, pretty small. 0 1/2, 2 2, 4 8. When we connect those dots, we get this shape here. What type of function is that, Maria?
An exponential.
That's an exponential function. So that's how we determine it, using a scatter plot, using a graph. Okay, scatter plot would have been a more accurate term if I hadn't connected the dots. So what we can see is that we know this is exponential because it's getting higher at a faster rate. Okay, it's not increasing at a constant rate like a line. If it was a line, eventually it would have to go to negative. This one isn't. This one is going to keep getting smaller and never go below 0. And so we have this curve that's going up. And we know it's not a parabola because parabolas, yeah, they turn around and they're symmetric. Okay, so that means it's not a quadratic function either. The next set of points they give us are -4 1, -2 2, 0 3, 2 4, and 4 5. So if I plot those, I should see what type of shape I'm going to get. I've got -4 1, -2 2, 0 3, I did something wrong there, didn't I? I did.
Yeah, you did.
Blame Isaiah. It's Isaiah's fault.
Always is. Or just blaming his Jedi mind tricks.
Yes, somebody used a Jedi mind trick on me. Alright, 2 4 and 4 5. What shape do those dots form? That's a line. So this is a linear function. Okay, forms a line. Pretty simple. Next set. Oh, we're getting there. We'll make it a little more complicated. It's an adult's payback on you guys being teenagers. You make everything complicated, so we're just returning the favor. Now, if we look at this here, if we look at just the collection of points, we ought to see kind of a pattern. Okay? The y values are going down, and then they're going back up.
Oh, it's
Only
like a
means
plus
one
1.
So we got -4 5, -2 2, 0 1, 2 2, 4 5. So what do we say? It's a parabola. What type of function is that? What's the function type called?
Quadratic.
Quadratic. Make sense? Yes, no, maybe? All right. Now, you can recognize these without plotting them with just a little bit of work if we have a table. Linear functions have a constant rate of change. And so if you look at a table, you'll know you have linear functions if the y's are going up by the same amount whenever the x's are. So the first thing you want to check is, when you're looking at your table, is make sure that the x's are going up by the same amount each time. Okay, if they're not, then it's going to mess with your results. So as we can see, those x's are going up by 1 each time. Now we look at the y's. Now they don't have to be going up by 1s, but they have to be going up by the same amount. If we look at the y's, are those all going up by the same amount?
Yes.
What are they going up by?
+3.
3. Okay. Since we can add the same amount each time to get the next one, this is a linear function. Okay. Since it's +3 between each one, that's a linear function. It doesn't have to be 3, but it has to be the same amount each time. So far, so good? The next table, keep the -1, 0, 1, 2. We'll go 0.25, 0.5, 1, 2. Are they going up by the same amount for adding? No, the first one goes up by 0.25, then 0.5, then 1. Not going up by the same amount, right? So what we could do then is we could check the quotient, the ratio. What's 0.5 over 0.25? Nope.
2.
2. Divide, not subtract.
Oh.
What's 1 over 0.5? 2. What's 2 over 1? 2. So since they have that constant ratio, okay, the ratios are always the same, we have an exponential function. So if you can't add to get to the next one, but you can multiply each time, it's an exponential function. So far, so good? Quadratic functions, on the other hand, a little bit different. So suppose our outputs are 5, 2, 1, 2, and let's go one more step. 5. Now, first of all, we see some symmetry there, right? So we might think it's a quadratic function, but there's a way we can check. What do we add to 5 to get to -2?
Wait, what?
What do we add to 5 to get to -2? Or to get to +2, sorry.
-3.
-3. How about to get from 2 to 1? How about from 1 to 2?
1.
How about from 2 to 5? Those all the same number?
No.
No. What would we add to -3 to get to -1? 2. What about from -1 to 1? What about from 1 to 3? These are called second order differences. Okay? The ones above them, the ones we checked for linear functions, were called first order differences. I'm not sure what first order differences are, because in the first order everybody's wearing the same armor. That was a Star Wars joke. Yeah. When the second order differences are all the same, we have a second degree function that's a quadratic. Now in Algebra 2, you'll learn that there's polynomials that have higher degree. You could have third degree polynomials. Okay? You can have what are called cubic functions or quartic functions. You can go 3, 4, 5. And so you can keep checking these sequential differences, and whatever level they're the same at, that tells you what type of function you have. So if we went down to the fourth set of differences, it would be a fourth degree function. This is the second order differences. So it's a second degree or a quadratic function. So you got 3 methods to check what type of function it is. Make sense?
Yeah.
So then the next step is once you've found what type of function it is, you have to find the equation. So let's look at example 3. Given a table, so the first thing we want to do is figure out what type of function we're looking at. Anybody have any guesses? Yeah. Why?
Because they're both on the same side.
Okay, there's a symmetry there, right? The outputs are going down and then back up, right? But let's check. What do we add to 2 to get to 0.5? Negative 1.5. What do we add to 0.5 to get to 0? And add to 0 to get to 0.5. And add to 0.5 to get to 2. Okay? Not the same, right? But what about the next order? What do we add to negative 1.5 to get to negative 0.5? 1. How about negative 0.5 to 0.5? And 0.5 to 1.5? So it is a quadratic. Now, can anybody guess where the vertex of this quadratic is? Yeah? Why?
Because the x is 12, but y is 0. And, okay, it's the only one on that graph that doesn't have a mirrors, which means...
There you go. It's in the middle of the 2 symmetric sides. That's what makes it the vertex. Now, when 0, 0 is the vertex, that means it's in this form. Okay? So we just have to figure out what A is. Any guess as to how we can figure out what A is? Yeah?
Take an x and a y with the same coordinates and plug it into.
Take an X and Y and plug it in. Now, there's only one point up there you're not allowed to use.
0,
0,
0.
0. If you use 0, 0, you're just going to get 0 equals A times 0, and that's not going to tell you what A is. So you got to use another point. So let's use 1, 0.5. Plug in 0.5 for Y and 1 for X. What does A equal? What does A equal?
Oh, you have to do the square root of 0.5, right?
No, because the A is not squared.
0.5.
A is just 0.5. 1 squared is 1, right? This would be 0.5 equals A times 1. So 1A is 0.5. So our equation is Y equals 0.5 X squared. Make sense? How would you like to be able to do most of this on your calculator?
Very much.
First thing we want to do, we're going to use this for example 4. So turn your calculator on, hit Stat, which is right below the delete button. And then once you've done that, select Edit. Now in L1, enter all of your inputs for example 4. And in L2, enter all of your outputs. Take your time, make sure you enter them all right. Everybody got them in properly? Now what we can do is we can use the scatter plot to see what type of equation it fits. So once you've got them in, hit second stat plot. Second stat plot. Stat plot is above the y equals button. Okay? Once you do, you should see stat plots, and then it should list all of those possible plots. Everybody good so far?
Why are they off?
Because you're not using them. They default to off. Okay, so select the first one. Okay, and it should open with plot 1, plot 2, plot 3 on top. So turn it to on. Make sure the type is scatter plot, which is the dots. Your X list should be L1. Y list should be L2. Does anybody have anything different? What's that? Hit enter.
I don't.
Okay, now select on and hit enter. Okay. All right. Now the X list should be L1. The Y list should be L2. If it's not, then just go down to where it is and hit second 1 or second 2, because second 1 will put in L1, second 2 will put in L2, and so on. Okay? And then there should be a mark at the bottom. It doesn't matter which symbol you select. I prefer one of the two on the left, so it's easier to see. The tinier dots are a little harder to see. Everybody good? Now, just to make sure that this isn't going to interfere with anything, go to y equals. If you have a function in there, either clear it out or hit the equals button. Go over to where the equals is and hit enter, and that will turn that function off so it won't show up when you graph. Okay. Then hit zoom and scroll down until you see zoom stat. And hit enter. That will give you your scatter plot. What does that look like to you?
An exponential.
It could be a line. It's got a slight curve to it though, so it's probably an exponential. You've got the wrong points in. Were you using these x values? Were you using this table? Were you using this table? Okay, we're using the table from example 4. Okay, you've got an errant point on there somewhere. So check your table and make sure the points are all right. Okay, if you enter the points properly, you should get something that looks like this, although it's going to be a little hard to see on the board. Okay. Now it looks like it could be linear, but there's a slight curve to it. Let me just highlight these points for you here. There's a slight curve to it, and if you check, if you look at the table, are those going up by the same amount each time?
No.
Okay, the first one goes up by 5.7 because I subtracted, and the next one by 6.2, the next one by 7, and the next one by 7.7, and the next one by 7.6. So they're not going up by the same amount each time. So that means it has a slight curve to it. So we should use an exponential function. Okay. So we can actually get our calculator to find the perfect function for us. So hit second quit so you're on the main screen. And then hit stat. And go to the right where you see calc. So the top of your screen should say calc, and then you should have a list of options underneath it. Screen should look Kind of like this. Everybody there? Now, since we said this is exponential, we want to do an exponential regression. So scroll down until you see expreg. On my calculator, it's choice number 0. It might be different for yours. Everybody good? So hit enter. And it depends on what type of list or what type of screen it brings up. So if you're on one of the newer TI-84s with the newer software in it, then it should have, at the top, it should say expreg, have X list, Y list, frequency list, store regression equation. Yes, yours doesn't, but I didn't expect it to. Good. Okay, so they got the 83s, and I'll walk you through here in a second. So make sure, first of all, if you got the older ones, or the newer ones, does it say L1, L2 for X list and Y list? Okay. Now, scroll down until you're right next to store regression equation. Okay? And then ignore me for a second. Okay? Liz and Spence, you've got the older one, so here's what you're going to do. You're going to hit, you should have just expreg on the main screen, right? So hit second one. That will put it in L1. Good? Then hit comma. Comma is right above the 7. Okay? Then hit second 2, which will put in L2. Hit comma again. Okay, now we're all going to do the same thing. Hit vars, which is right next to your clear button. Stands for variables. Okay? Everybody good? Vars. Right there. Okay? That stands for variables. And go over to the right so it says Y vars. Everybody good?
Mm-hmm.
Select the first option, function. And then select whichever one you want. I would use Y1 if you don't have anything in Y1. Okay? And so now it will go back to your expreg screen. And if you have the newer ones, it will look like mine. If you have the older ones, it will say expreg L1, comma, L2, comma, Y1. Yes? Hit enter. Uh-oh. You've cleared out your list somehow. You're in the wrong space. I'll explain to you how to do it when we're done. Okay? You good? All right, once you're done, if you're on the newer ones, go down to calculate, hit enter. If you're on the old one, just hit enter.
Points.
Whoa.
So now what it does is it tells you exactly what function you need to fit your calculator, to fit your graph. So your screen will look something like this, although you may be missing the R values. And that tells you exactly what exponential function fits that data.
That's cool.
So what you do is you say, okay, they say that A is 6.39. So, and they give you the form, they say Y equals A times BX. So you just plug it in, you say A is 6.39. And B is approximately 1.11 to the X power. There's my function. And if you have an R value there, that tells you how well it fits your data. So in my case, R equals 0.9999998. The closer that number is to 1, the better it works. Okay, now that's pretty cool, right? I'm not done yet. Hit graph.
Oh, that is cool.
Yeah.
I'm writing all these instructions down.
Yeah, it's fine.
I think I can remember.
I know, me too. I'm like,
I could, but mine didn't show up. Oh, that's why I didn't. I'm in sequence mode from a different class.
So you can
Let's try that
do
again. There we go.
So you can do like with the exponential and like with the linear and the quadratic by doing the same steps.
Yes, just a second. Alright, so it fills it right in. Now, everybody good? And we can see how well that curve fits our data. Because that curve goes right through the points.
It's really well.
Okay? If it doesn't fit the points very well, you did something really screwed up. Okay? Or it could just be that the points aren't that perfect, and they might be off the line a little bit, but they average out to be pretty good. Now, just for kicks, just in case, hit Stat, go over to Calc. If you notice, choice number 4
Linear.
says lin reg. That's for a linear function. So if you determined that your function fit a line, you can use that. We did those earlier in the year, I believe.
Yep.
Right below linear regression is quadratic regression. So if you determine that it fit a quadratic function, if it was a parabola, you would select that. And all the other steps are exactly the same.
Oh my word, that is
Okay.
so cool.
So that will help you find the equation for your data. That makes sense?
So, if
Any
it-
questions? Yes.
So if it's exponential function, then we had.
Then we use
That-
xbreg. Yep.
Okay.
Okay.
Well,
Any other
I need
questions?
to write these down.
All right.